We are pushing modern AI to its absolute breaking point. Today we subject Gemini and GPT-5 to the ultimate stress test. We're forcing these models to process 50 dense technical white papers simultaneously. That's over 2 million tokens of raw data. Can Gemini's massive context window actually outlast GPT-5's architectural efficiency, or will the logic fracture under the pressure? Watch as we expose exactly where these models lose the thread. This is the battle for long context supremacy. In this first stage, we're looking at raw ingestion. How do these giants handle a massive flood of information? Google's Gemini is designed for brute force attention. It utilizes what engineers call ring attention to manage context. It essentially wants to hold every single word in active memory simultaneously, ensuring no detail is lost during ingestion. GPT-5, on the other hand, is rumored to use a more efficient recursive architecture, often referred to as recursive distillation. Instead of raw storage, it distills data as it goes, building a hierarchical summary to save on computational resources. On the surface, both look stable, but as the token count climbs toward 1 million, the hidden cost starts to show. Processing latency becomes a critical factor. Gemini's brute force requires massive VRAM, while GPT-5's recursion adds logic overhead. This leads us to the most dangerous part of large-scale models, reasoning drift, where the logic starts to fracture. We asked both models to identify a conflict between a variable in document 1 and a conclusion buried in document 48. This requires global coherence, the ability to maintain a single logical thread across the entire 5 million word stack. At 1.2 million tokens, Gemini's perfect memory starts to blur. It remembers the data exists, but it fails to connect the dots. It's like a librarian who can find any book in the archive but has forgotten how the story in the first chapter ended. GPT-5, meanwhile, suffers from hallucination fatigue. Because it relies on summaries, it starts to fill in the gaps with its own logic. It synthesizes an answer that sounds technically correct but actually ignores the fine print found in the middle of the document stack. This is a known architectural flaw, called the middle loss problem. Most models prioritize the beginning and the end. The middle tokens are often compressed or lost during the attention pass, leading to catastrophic errors in multi-document research. To find the ultimate breaking point, we ran the Needle-in-a-Haystack challenge, the gold standard for context testing. We hid a specific API key modification inside thousands of pages of complex data. It was placed in document 37. This is the ultimate test of retrieval. If a model misses this, it cannot be trusted for mission-critical enterprise applications. Gemini located the needle with remarkable precision. Its brute force approach ensured that document 37 was still in active memory. However, it struggled with the logic of how to use it. It found the key but couldn't explain its role in the larger script. GPT-5's result was much more concerning. It completely hallucinated a different key that didn't exist in the data at all. The model was so confident in its summarized version of the context that it missed the specific needle entirely. When the pressure is on, retrieval is only half the battle. At these scales, coherence is what truly matters. If the AI can't remember the why along with the what, the entire system begins to collapse under the weight of its own context. Beyond retrieval and logic, there's the question of stability. How long can these models stay online before failing? At 2 million tokens, we saw significant latency spikes. Gemini's response time slowed to nearly 40 seconds per query. GPT-5 was faster, but at the cost of accuracy. It was returning empty responses after just 12 seconds of processing. The brutal reality of large-scale logic is that no AI is perfectly stable at 2 million tokens, at least not yet. For enterprise users, choosing the wrong model for multi-document research could lead to catastrophic analytical errors. So who wins? It depends on your needs. Gemini is your librarian. GPT-5 is your creative director. Gemini takes the crown for raw retrieval and attention stability. If the data is there, Gemini will find it, even if it struggles to use it. GPT-5 wins on synthesis and reasoning speed. It's much faster at connecting disparate ideas, provided it doesn't hallucinate the facts first. I've linked the full benchmark results and technical white papers in the description below for those who want to dive deeper. This technical breakdown was brought to you by Vendak. Visit vendak.com for high-fidelity digital art and exclusive fashion drops. Subscribe to Kado Stratify for more AI stress tests and technical deep dives. We're pushing the limits every single week. Hit that notification bell to stay updated. I'll see you in the next one as we continue to explore the frontiers of AI logic.